Okay, so we're going to start with the simple gas laws. We're going to start with Boyle's law, and Boyle's law involves pressure, big P, and volume, big V. And you need to remember from previously that pressure is affected by either how often you have collisions occurring or how hard those collisions occur. So we need to think about, how does volume affect one of those two things? Is volume going to affect how hard collisions occur or how often? And in fact, they affect the how often. So if you have a smaller volume, means particles are colliding more often. So colliding more often, and when you have particles colliding more often, that means you have an increase in pressure. Okay, so a smaller volume means a greater pressure. Those things are opposite, which means that these have an inverse relationship. And it's important to remember that pressure and volume are the only ones that have an inverse relationship. So these are going to make a graph that looks something like this. It's sloping downwards. The other thing to remember about Boyle's law is it only works in flexible containers, right? The volume has to be able to change. If it can't change, then Boyle's law is not going to be in effect. So we're looking at things like balloons, things with a piston in them. You'll see things with syringes. They also have that plunger, which acts like a piston that can move back and forth. Okay, so we've got this little app here, this little GIF that's going back and forth, and this is what it means by having a piston. So you can see the number of particles in that chamber are staying the same. You're having those little weights on there which are squishing down the volume, and as this volume gets squished down, the pressure gauge on the left is changing. Now, for that to be able to work, you have to see that the number of particles is staying the same and the temperature is staying the same. So if you shrink the volume, the pressure goes up, and that graph on the right looks exactly like the graph on the previous page. So the formula for Boyle's law is P1V1 equals P2V2. And the thing to remember is that the pressure and volume can be in any unit. So our pressure units, we have ATM, we have kilopascals, millimeters of mercury. So you're going to see any of those things being used. The thing to remember is that pressure 1 and pressure 2, they just have to be in the same one. You can't have one of them in atmospheres and one of them in kilopascals. That doesn't work. For your volume, you're most often going to see milliliters or liters, and again, same thing applies. Volume 1 and volume 2 just have to be in the same unit. So that being said, what you're going to need to be able to do is use some basic algebra here, because you are going to be given 3 out of these 4 variables, and you need to be able to solve for the one that it's asking you for, and you never know which one the problem is going to be asking you for. So this is dealing with multiplication, and if I'm dealing with multiplication, to clear out or to remove a variable that's multiplied, I have to do the inverse operation, which means I have to do some division. So P1 and V1 are multiplied. To isolate P1, I have to divide both sides by V1, which is going to give me P2 V2 over V1. Likewise, volume 1, I have to clear out the P1, which means I'm going to have to divide both sides by that P1. P2 and V2 look exactly the same, just switch the numbers. So I have to clear out the V2, so I'm going to have to divide both sides by the V2, so P1 V1 equals P2, let's see, divide that over by V2, and then same thing, P1 V1 over P2. So for a sample problem, Zippy, this is the same one that's in your book. Phil's favorite red balloon. The volume of the balloon is 5 liters, so I'm going to call that V1. That's in Seattle at 101 kPa of pressure. I'm going to call that P1. And I know that these two things go together because it says this word, at. This volume at this pressure. That preposition right there ties those two things together. So he takes the balloon to Colorado where the atmospheric pressure is only 91 kPa. That's a different pressure. If the temperature is the same, all right, so that's constant, that's good to know. What is the new volume? So that's V2. So I'm asking about the volume. So what happened to my pressure? Well, my pressure started at 101 and it went down to 91. So my pressure decreased. So if my pressure decreased, well, these are inverse. So my volume should increase. It is helpful to go through that thought process so that you know what answer you should anticipate. So I can go ahead and set this up. I'm looking for V2. So on the previous page, that was V1 and P1 multiplied divided by P2. So plug those numbers in. Open parentheses, 101 kPa times 5.0 liters, close parentheses, divided by 91 kPa. Okay, my kPa's cancel out, so that's leaving me with this liter unit, which is what I want. I have 1, 2, 3 sig figs there, but 1, 2, and 1, 2. So my answer should have 2 sig figs. So my calculator, I'm going to open a parentheses, 101 times 5.0, close a parentheses, divided by 91. My answer is going to be 5.5 liters to 2 significant figures, and in fact that did increase, so that seems to make logical sense.